Absolute encoder types and identification. Understanding absolute encoders. Absolute encoders are a type of rotary position sensor that provides a direct digital reading of the shaft's angular position, unlike incremental encoders, which require a reference point to determine absolute position. Absolute encoders can provide accurate position information without external referencing. Types of absolute encoders. Optical absolute encoders. Gray code. Each code word differs from the previous one by only 1 bit, ensuring that there are no ambiguous readings. Binary code uses a standard binary representation but can suffer from ambiguity during transitions. Sinusoidal encoders generate analog sinusoidal signals that are then converted to digital form. Magnetic absolute encoders. Magnetic rotary transformers use magnetic principles to transfer position information. Magnet-resistive encoders utilize the change in electrical resistance of a material due to a magnetic field. Other types, capacitive encoders, measure changes in capacitance based on the position of a rotating element. Inductive encoders detect changes in inductance due to the position of a rotating element. Identifying absolute encoders. Labeling. Look for labels or markings on the encoder that indicate the type, e.g., absolute encoder, gray code, binary code. Output signal. Check the output signal of the encoder. Absolute encoders typically provide a digital output, while incremental encoders may provide a pulse or frequency signal. Resolution. The resolution of an absolute encoder is determined by the number of possible position codes. Higher resolution encoders have more code combinations. Interface. Consider the interface type, e.g., parallel, serial, quadrature. Absolute encoders often use serial interfaces like RS485 or CAN bus. YouTube video outline. Introduction to absolute encoders. Definition and basic principles. Comparison with incremental encoders. Types of absolute encoders. Optical gray code, binary code, sinusoidal, magnetic rotary transformers, magnetoresistive. Other types, capacitive, inductive. Identifying absolute encoders. Labeling and markings. Output signal and interface resolution. Applications of absolute encoders. Robotics, automation, motion control, machine tools. Visual aids. Diagrams of different absolute encoder types. Examples of encoder labels. Animated demonstrations of encoder operation. Additional tips. Use clear and concise language. Provide practical examples and case studies. Consider creating a tutorial series for in-depth coverage. By following these guidelines and incorporating visual aids, you can create a comprehensive and informative YouTube video on absolute encoder types and identification.